good morning, everybody. So I will be chairing now the first panel session. I would like to invite the panel member to sit down here, maybe, so that we can discuss. So I would like to have Dr. Chris Phiri. Charles Phiri. Yeah, excellent. And then Dr. Eleonora Giunchiglia. Fantastic. And Dr. Jones. And we have co-chair Dandan Zhang. Fantastic. So let me introduce, thank you for coming here. So let me introduce myself first of all. My name is Alessandra Russo. I'm a professor in applied computational logic at the Department of Computing. And I'm also Deputy Director of UKRI Center for Doctoral Training in Safe and Trusted AI. So my research focus is predominantly in safe and trusted AI. And I think we have here fantastic speakers. I would like to just comment on last-minute cancellation, unfortunately. We were supposed to have Wamin Sik, who is the CEO of Fetch AI, but unfortunately has been called last minute last night for a flight to US for some commitment with his company. So I apologize for him not being here. Anyway, we have fantastic speakers here. So, and really the topic of this first panel is on generative AI. It's artificial general intelligence. We saw incredible results from Stefanos in his previous talk about the amazing advancement that AI is making. So from the point of view of facial recognition, speech, and 3D image regenerations and so forth. But clearly, we want to expand a little bit more the scope of this discussion. And really, we want to explore the area of what people call artificial general intelligence. And really, what are the challenges that we are facing today, both in research and in industry, if we wanted to realize a future where actually, the promise is the machine can actually perform tasks comparable to human tasks, with demonstrating same cognitive ability as humans. So we have a number of questions we're going to go through in this panel discussion. But before starting that, it would be nice to introduce individually every single member that we have here. So should I maybe actually let you introduce yourself? So it would be best than me introducing you. So should we start from left to right? Charles.
Thank you. So my name is Charles Phiri. I am a subject matter expert for AI and ML innovation in JPMorganChase, where I work as the executive director and principal architect in the global enterprise architecture team. So as part of this team, I'm actually landing different technologies, including AI ML, into the firm and making sure that we can do this in a governed way. And for those that are not aware, JP Morgan has got a lot of AI and, of course, quantum research and other types of, research that we are doing. The idea is actually to bridge the gap between the research that we're doing and the engineering that happens within the firm. So that is actually where I'm sitting. So we've got things like the expert engineer programs that actually take in different, let's say, individuals from academia and bringing them into the fold with the firm, and making sure that they understand how to work with highly regulated environments. My background is hardware design engineer turned into software systems engineer turned into humanoid robotics researcher. So I've worked on a lot of firsts, including the OneWeb satellites, the Japanese large impact robots, bringing in the different sensor technologies with Infineon semiconductors and also Bluetooth 4.0. I've worked in the semiconductor industry. I've worked with medical devices, so we can talk about things at multiple levels. So that's why the name in the title where it says subject matter expert for innovation, that's not well defined in JP Morgan. So I get to do everything. Thank you.
Okay, great, thank you. So, Eleonora.
So, hi everybody, I'm Eleonora. I'm a new lecturer here in Imperial, and I work a lot on neurosymbolic AI, safe AI, and in particular on how to build deep learning models that are compliant by design with a set of formally specified requirements.
Thank you. Ed?
Thanks. Hi everyone. So my name is Edward Johns. I'm in the Department of Computing, and I'm director of the Robot Learning Lab. So if you imagine you have a robot with a head, like a human head, with cameras for eyes, and an arm with a hand on it, or a couple of arms with a couple of hands, and you want that robot to perform some tasks with its hands. You throw a bunch of objects in front of that robot and try to get it to learn skills with its hands, whether that's assembling objects in a factory or stacking dishes in a dishwasher, whatever it is. I'm trying to get robots to learn these kinds of skills with their hands very, very efficiently without requiring too much data, because it's very difficult to collect data in robotics.
Thank you.
Thank you. Hi, everyone. My name is Dandan Zhang. I'm a lecturer at Imperial X, and also I am a lecturer at the Department of Bioengineering. My research interest mainly lies in the intersections of robotics and AI in healthcare application. And my research lab mainly work on intelligent robotics in different biomedical applications, including surgical robotics to conduct minimally invasive surgery, and also micro-nano robotics for different biology application, like micro-nano robot for cell manipulation and intelligent micro-nano robot for drug delivery. And this can contribute to precise targeted treatment. My ambition is to develop artificial intelligence and robotics to support the future healthcare 5.0, which represent the sustainable healthcare utilizing artificial general intelligence technology. Thank you.
Okay, fantastic. So, all right, so let's start to dive into this discussion. Clearly, we've seen amazing advancement of AI. Stefanos was illustrating some of the incredible results. And people use a different terminology. They talk about the generative models, they talk about large language models, and now we are talking in this panel about artificial general intelligence, right? So, which sounds even more, grandiose than all what people call a narrow AI type of technology. So, I think we should maybe start kicking the discussion with, what do you think in your respective sector of work, of applications, what do you think is artificial general intelligence? So should we try maybe to give a little bit of a definition of that, right? However possible it is, actually. So who wants to start? Maybe Charles, since you're here? Yeah, next to me.
So I think the term artificial general intelligence, I mean, the way I look at it, first of all, it's not something I actually worry about. I mean, it doesn't keep me awake, at night. It hasn't started yet to actually keep me awake. But when I look at artificial general intelligence, as it is actually defined by or talked about in the media or even in the academia, I'm actually looking at 4 separate points of view. So the first one is if we take the Turing machine, there are actually there are actually 2 parts to it. That there is actually an agent that is actually supposed to be intelligent, and there is an observer that is actually looking at that agent. So it's, if the agent is actually is clever enough, and the observer says, oh, this is actually this is actually clever, and it is actually doing everything as a human. Maybe you can actually call that, if it's actually going beyond different narrow scopes, you can actually maybe call that as being really an intelligent, an intelligent system. But I'm actually more concerned with the third person who's observing these two, right? If they've got enough knowledge about both the observer and the agent, right, would they call this, as being intelligent given the current systems that we have? So if I'm looking at, for instance, the generative AI models, right, the current architecture, I'm not convinced that it's going to give us anything that is actually going towards the artificial general intelligence. As I still haven't defined it, but still, it is actually not going to give us anything that is actually more intelligent than what we have, right? this, you can actually see the evidence by the fact that if I take the transform architecture or the GPT models, I need to also add the things like the knowledge graphs. Knowledge graphs have got a limit in the amount of information that you can actually represent with them. So when I'm looking at the questions that I can answer with the current technologies, I'm still in the narrow domains. Right? So if I cannot actually combine several narrow domains to actually give me something that is actually high fidelity. So for instance, if I'm taking a digital twin of an aircraft, right? Put a dent on it and see how much data you need just to actually model that that information. So take the human, let's say our environment, which is actually non-stationary, and add all the nuances that would have to actually have this, let's say, intelligent agent actually take care of. I think we don't have enough power. We don't have enough hardware, capabilities to actually go past that. Now, the fourth person, looking at this third person, what should they see? So I see this as a philosophical question that doesn't have proper boundaries at the moment.
Okay, so then you're talking about the difficulty about generating agent will actually behave in the same way as a human behave, right, when solving a particular task. So, Eleonora, from your angle, what really would make a computing agent, call it, having a general intelligence? So what would you see? What would you expect to have?
Okay. Well, it's a difficult question, right? Because I think the concept has evolved a lot over time. Because if we think about, ChatGPT, and we were presenting this to a scientist 10 years ago, then probably he would have argued that that was AGI, right? Because it's able to talk about a lot of different things. So I think the first point we should take into consideration is that the concept of AGI is actually an evolving concept, and it's evolving from our perspective. I think for me, obviously personally, because again, it's a fuzzy concept, it's for sure an agent that can deal with a lot of different scenarios, such as ChatGPT, but it's not only able to learn, but it's also able to reason, right? That's important. And it's also able to explain the reasoning that he has done. And I think also it's very important, we are really missing right now is that it should be an agent that has some sort of autonomous thinking, so it's able to decide when to learn, when to reason, when to forget, and it's able to move in the world or act upon the world, which is something that I think we are really missing as of now, and probably for me at least, it's the main difference between a narrow AI and an AGI.
Yeah, maybe following up a little bit on that, Ed, I know you're more concentrating on visual robot manipulation, but if you want to scale this up to humanoid type of robotics, right? So, people talk about general intelligence when they refer to consciousness, self-awareness, or these other more philosophical questions. So do you think that's really what defines general intelligence, or what is it from the angle of robotics? What do you see your definition of general intelligence to be?
Yeah, I kind of see AGI as, let's say you could just take the average human and bring in something else to do the same things that that human can do. If you can do that with the average human, then I think we have AGI. And I think to a certain extent we've achieved that in some domains, with language, for example. Like ChatGPT is as good as a lot of people in reasoning about some quite complex topics. But from the robotics perspective, we can't simply replace or bring in AI and do the same jobs or tasks that humans can do physically. Because it's very, very difficult to get robots to work. The robots in my lab are rubbish, in all honesty. And that's not because I'm a really bad researcher. It's because it's just really, really challenging to get robots to physically interact with their world, even though that's something that's really easy for humans. So I see AGI from the robotics context of not just the reasoning in the brain, but also the reasoning with physical interaction with the world. And that's something that's really difficult to achieve in AI at the moment, because most breakthroughs in AI have come from really, really large data sets. And that's quite easy to obtain from computer vision or language communities, but in robotics, we just don't have that scale of data. So we have to be much more creative as to how we can actually achieve AGI in robotics without just kind of relying on large-scale data collection.
Yeah, just maybe to conclude on this topic, I mean, definition of AGI, maybe then if you want to comment a little bit about what are the social economical opportunities. Let's assume we do get to a situation where we can have AGI, agents that have demonstrated general intelligence. What are the social economical opportunities that such, machines will be able to offer to our society and economy and industry? And in which domain in particular?
Yes, thanks for the question. So as mentioned before, I mainly work in the healthcare, and also robotics and AI is my major research interest, but slightly different from Ed. Maybe Ed work more on the vision-based robot learning, and I work more on the robots in healthcare application. And I think what I understand about AGI for healthcare application is that the AI is not only able to solve a very specific task, because currently many research groups are all working on robotics AI in healthcare, but they all end up solving a very specific task, like develop an intelligent surgical robot to autonomously finish a robotic surgery, or develop an AI model for diagnosis. So from my perspective, so artificial general intelligence in healthcare means that we can have a very intelligent, personalized assistant, and this is an intelligent assistant with super intelligence and can solve many different tasks, such as can contribute to early diagnosis and intervention. For example, when you feel unwell, you don't need to make an appointment with GP waiting for a long time, and can just ask your digital virtual intelligent doctor to get some initial advice. And when you really hurt yourself because of some injury, we can also have an intelligent, personalized surgical robotic systems to take care of the surgery in a minimally invasive mode. However, currently, the narrow AI all focus on very specific tasks. We still do not have such a very powerful personal doctor. So I think that in the future, towards healthcare 5.0, it's very important to have such kind of intelligent digital doctor, and also can conduct some surgery at home.
Okay, so healthcare is clearly an important domain, so there are many other important domains. I suppose, Charles, in your sector, what do you think would be, I don't know, the technical challenges that we will need to actually address if we wanted to achieve some form of general intelligence, I don't know, in the financial domain, let's say, that can help us in the financial domain?
I think the first thing that we'll actually meet is the regulator, because the regulator is actually very, very much bullish when it comes to different technologies. And I mean, it's not that they want to punish, but they are actually looking at the technologies, and they have to look at what are the risks around it, right? So if we have actually got an intelligent agent that has got its own motivations, and it's actually working with a lot of financial data and a lot of information that we provide to it, we also have to worry about what it can do with that data, right? So if you actually take on a day that we are actually processing over 9 trillion transactions for different entities, we cannot actually truly just say, okay, we're going to do this without actually considering the risks. But at the same time, we have to also look at, if somebody has actually got this technology, then we need to actually be there first to make sure that we can guard against what the regulators actually worried about. So that's why we spend so much time in research, and also we are looking at things like how do we actually bridge the gap. So within the organizations, you've got blue teams that are actually trying to actually bring the technologies, but we also have to have red teams that are actually trying to break this technology, and we simulate both. So that's what keeps us busy every day, trying to understand the architecture, how to learn the technology, and then we also need to understand how that technology, if broken, would actually impact everyone.
Yeah, I mean, clearly regulations and risk are really important aspects in artificial general intelligence. So Eleonora, thinking about, you mentioned neurosymbolic AI, right? So from a technical point of view, technological point of view, even if we have the most wonderful regulation framework in place, right? Would we have actually the mechanism to control, let's say, these artificial general intelligence agents? And what would we need? What are the technical challenges you think in order to be able to do that or to achieve that?
Okay, this is a very complex question.
That's
like,
right, correct, yes.
It's not easy. I think, for example, in neurosymbolic AI, at least we are starting acknowledging that there is a problem, the fact that, machine learning is not just a statistical model, but it's actually becoming a system that acts upon the world, and so we need to have, some sort of regulations upon that. And I think, while in neurosymbolic AI, it's very, people are aware of this, not everybody in the world is still aware of the problem. In terms of what it has been done, well, I'm one of the people that is working on this, so we are trying to define models that are compliant by design with a set of requirements, for example, which means that essentially you define a priori what you want your model to do, and then you design a model that is guaranteed to behave in that way. There are other works that have been done, for example, in verification field, which take a model, and essentially what they do is, okay, they have this model, it's already trained, and then they verify that the model is compliant with the given requirements. And finally, very much in software engineering, there are testing techniques, right? So there are techniques essentially that test the model on all the possible input space, and then they see how it behaves. Is this enough? No, but we are studying, so I hope we will get there. And I mean, if I can add on your point on the finance, I think in general we shouldn't just, there is the problem of AI alignment, so there is not just the problem of an agent that suddenly turns evil or anything, but there is also, in my opinion, very much the problem of badly defined machine learning models, which means that you, as a software engineer, data scientist, try to define a model and you expect it to have certain behavior, but while in software engineering, you can just write line by line what your model is doing. In machine learning, you don't know exactly what is going to happen, and this sometimes can lead to very unexpected outcomes. And so, for example, if in finance we give one model that is not behaving exactly how we expect, like access to trillions of actions per day, then it can be very, very dangerous. So yeah, we need to do something, and we are studying, but we are very far away from a solution, in my opinion.
Okay, but we are going to have, hope for the future? So
yes,
yes,
okay. Yes, there is hope.
We'll explore also the audience opinion on that.
No, there is hope.
Once we go through all this. So I think clearly you said we are not there yet.
We are not there yet.
So, okay, Ed, maybe I want to, pinch your brain a little bit on what do you think what are the measures that we should actually put in place to be able to say, are we there yet? Have we achieved general intelligence or not? So you talked before about being able to solve tasks, right? So clearly there is a lot of cognitive abilities that these artificial general intelligence agents needs to demonstrate to have, right? To be called AGI, all right? And there are various tests. People in the past talked about the Turing test, to see whether, but maybe people say, okay, large language model already passed the Turing test, right? So what do you think it should be from your angle, the kind of measure, milestones, and KPI that we think we should have in place to be able to say, okay, can we assess whether this agent is truly an AGI agent or not?
Yeah, well, I think if we go back to that definition of AGI being as capable as humans in all the things that humans can do, that includes the ability to learn quickly from a small amount of data. And ChatGPT is kind of cheating, really. It's seen way more books than we've seen. And it achieves what is apparently human-level intelligence in a kind of black box sense, but it's seen a lot more data than humans have in terms of the textbooks that it's read. And so I think one milestone would be, can AI learn rapidly in the way that humans can? particularly in domains where there isn't actually very much data. So in robotics, for example, can a robot learn a physical skill? Can it learn to play tennis, or can it learn to play a musical instrument with the efficiency that a human can? So I think that ability to adapt and learn quickly is something that we haven't seen yet. We may not care about that, like in terms of the applications, who cares whether this thing has seen more or less data than humans? But if we really talk about the science of AGI, then I think we need to see AI learning as rapidly as humans. But then I also think it's important to, it's going to be very difficult to evaluate very, very powerful superhuman AI in narrow domains, because by definition we don't actually know what the answers are to some of these things that we're asking the AI. So if it's something like asking AI to design a cure for a disease, how do we actually know whether that cure is going to work without testing it out on humans? Like, we can't really evaluate it until we try it out. So I think in these narrower domains where AI will be superhuman, it becomes very, very difficult to actually evaluate, and really challenging to know what those milestones should be, because we as the humans are somewhat out of control. We don't really know where this AI is going. We don't know whether the things it's thinking about are correct or not, because we don't understand that domain well enough. So I think that narrow superhuman AI will be much more difficult to come up with these milestones.
Okay, do you think, maybe Charles, do you think that industry has got a role in helping, understanding that, right? Clearly, data is one of the issues, and maybe the, interaction with experts in specific domain is another issue to be able to ascertain, the ability of these AI agents. So, what do you think would be, what role do you think industry can actually play in terms of, helping out? Assessing or whether we have achieved or not, we are moving towards artificial general intelligence.
I think the first thing is for industry to be in rooms like this.
Yeah.
But also, I'm actually looking at, let's say, we've got companies like, of course, you've got our company, like JPMorgan, which has got 200 years of history. In those 200 years of history, there is actually quite a lot of information that we've actually collected and learned, right? Now, if we bring that information into this room is actually full of, a lot of people that are actually inspired to solve specific problems, and they can look at this data differently. So it's a matter of combining the inspiration that you get in co-locations like this, plus the financial muscle that is actually coming from from the industry and the experience of the real world in order to actually have effective collaborations, right? If you're actually coming in from the industry, for instance, the majority of people that actually make it to the top have actually learned through the engineering domains. Now we are telling them, we're actually bringing in this beautiful thing called AI. It's cool, and the marketing teams have actually done quite a lot of work to actually put it on all billboards, right? So even all the toys that we have, even the soap in my bathroom has got AI apparently. But anyway, the point is, when you've got the noise, you've got the hype, and you've also got the incentive that comes from the technologies making it out to the market. You've also got the problem that you've got the individual who knows how the system works but doesn't have a voice. You've got the individual who's got the money but does not know how the technology works. And then you've got the gap in between, that how do you get these two in a room in order to actually have effective solutions, and those solutions must represent the society in which we are actually working in. So if you, we have been talking about generative AI, but most of the data we are talking about is from the connected world. There is still about another 5 billion of people that are not connected, right? Effectively connected. And even the data in there, if you've got the data, you don't know whether you can trust that data, because the incentive to collect that data is always actually coming in with, if you don't do this, you'll be punished, right? If your country is not actually compliant with this, you will actually get, you will actually be demoted in this particular area. So people will collect data, but that data is actually not useful, right? So it's actually learning the methods of, one, getting that noise out, and two, coming into the rooms like this and combining the real-world experience, academic experience, and building a future that is actually more informed than where we are sitting today.
Yeah, I think this is quite right. So really, you're alluding to the need to have a kind of more holistic approach and interdisciplinarity type of collaboration that brings together people with different expertise. And I think one of the particular important angle on that is, you touched a little bit upon this before, with talking about risk, right? So one of the important angles of this is actually ethical consideration, right? So of the use or the deployment of AI solutions and AI systems, so whether they got or not to the level of general intelligence, right, yet. So what do you think are the, so Eleonora, what do you think are the ethical concerns that we really needed to, let's assume for the sake of argument that we have this AGI agent, somebody introduced this AGI agent into some kind of company organizations, and we see this happening already a little bit, right, under the carpet. So what do we have to be worried about? What are the ethical concerns which really, really are, close to us? Yeah.
So I think the first thing we need to take into account is the fact that these systems can be systemic. So like, when we talk about fairness and bias, these things are important because if one judge is biased, then he can influence the lives of 100 people. If ChatGPT is biased, then he can influence the life of billions of people. So this is why we talk so much about ethical considerations. And this spans over so many things. I talk about fairness. Fairness is an important one. We have problems with respect to like, who takes the responsibility when one of these AI models, one AGI model, takes a decision. So this is an open question, but nobody knows the answer to, because like companies obviously don't want to be liable for the AI models they develop, but meanwhile these AI models take decisions as if they were humans. So who is going to pay if they make a mistake? This is an ethical consideration we need to take into account. There is obviously the entire problem of interpretability. Again, if they make a mistake, why did they make this mistake, right? So, I mean, there are a range of open questions, and I think obviously fairness is the first one of them, but it's much deeper than that. And again, researchers are studying on this, and not only researchers, also philosophers, lawyers, and companies, because obviously they are developing their own AI models and they don't know when they apply them what is going to happen. I mean, the EU has done a bit of work on regulating their use, but that's just the first step again.
Okay, so then related to that, Eddie, from the point of view of robotics, would you think that people seem to be quite scared about robots taking over human task, right? So, transforming completely the workforce profiles of our society, right? So, eventually. So, do you think this is an important ethical consideration? This is a true risk that we have? Or if we project ourselves to, I don't know, 30 years' time in the future or something, is it something really that we have to be concerned about and try to safeguard ourselves to that? So, how can we, protect ourselves towards this, if such a risk truly exists? So first of all, do you think it's a risk? Or in second, how can we control it?
I think people, from people I speak to outside of academia, have become less worried about robots and more worried about the kind of software side of AI, so things that aren't tangible. So this idea of the Terminator robot causing an uprising seems to be less talked about now than maybe 10 years ago. And it's more about AI hacking into computer systems and controlling computer networks and things like that. But in terms of physical robots, what are the risks that we have there? Well, I think there are certainly big changes that might happen in the workforce. I don't see that as being any different or any worse or any more disruptive than the changes that will happen in non-robotics domains. I think that AI will change all of the workforce, and people will change the jobs that they have. A lot of tasks will be done by AI. I think maybe 10 years ago we thought, or 20 years ago, we would have thought that the first jobs to go would be those jobs that robots would take, so physical labor. Actually, it's probably not quite like that now. It's probably the sorts of tasks that do require training in some narrow domain and getting some kind of expertise in that domain. So I think actually that's going to be more disruptive in terms of jobs than physical robots. But looking to the future, yeah, I think we will have physical robots doing a lot of jobs. I think it'll be a slow introduction. I think, as I said earlier, robots are pretty rubbish at the moment, and we've got a long way to go. I think we'll learn a lot from the disruption that AI will have before we have that disruption from physical robots. And so I'm not too worried about what will happen there. And if people do have to change their jobs, then I think we've seen that happen in other technological revolutions. So people have sort of reskilled in other areas as machines have come in the past over the last few hundred years, and that seems to have worked out okay in the long term. So I'm not too worried about that. So overall, I'm kind of sort of offloading that worry to the people just working in AI for now, and then maybe I can learn some lessons from that.
Yes, great, thank you. So, and Dandan, just what, I mean, you mentioned AGI in healthcare, right? Mm-hmm. Clearly, there are a lot of risks there, in particular if you think about one day general practitioner will be replaced by an artificial general intelligent agent, right, who can actually do the early diagnosis of patients. So what kind of measures do you think and what role the industrial or the business sector needs to play in order to mitigate whatever risk could happen here?
Okay, thanks. I feel that healthcare is where the ethical issue that becomes the major hurdles. And because I have a slightly different point of view compared to what Ed mentioned before, because in healthcare scenario, imagine if a surgical robotic system go wrong, will bring unrecoverable damage to the patients and hurt the delicate tissues and so on. It's very dangerous. And also if the AI in healthcare make a wrong decision, and then if they cannot diagnose the disease in the early stage, that may bring a lot of troubles to both the hospital and the patients. And I feel that in healthcare, to be honest, safety is normally the current major important point compared to instead of intelligence. And I think for current AGI in healthcare, a very difficult point is collecting data because of privacy issue. And currently, because like ChatGPT and other large language models have already shed light to general intelligence in service robot, like serving people's daily life, help people take care of elderly people, do some household tasks and so on, cooking and so on. But in medical domain, this is still there is still a long way to go, because if the robot is only serving our daily life, if it goes wrong, then we just restart the system. But if surgical domain, the problem will come from who take the responsibility, whether the intelligent surgical robots should take the responsibility, or whether the hospital and the surgeons. So I feel that in the future, there are several things that several technologies still need to develop before we can really apply AGI in medical domain, like how to develop trustworthiness in intelligent surgical doctor, and of course how to protect data privacy for patients, like using federated learning technology, because most of the large language model nowadays are benefit from collecting a large amounts of data using the web. But for healthcare data, it's very difficult to assess this kind of data to change the large language model. So I think that in the future we have several technical developments still need to emphasize, and the business partner can contribute to how to use federated Internet of Robotic Things technology, which means that the model training is on the cloud using cloud computing, but the cloud didn't access the data. The patients didn't upload their data to the cloud, but the data training is done in the local computer, while the model can be upgraded on the cloud. So, yeah, this is just my point of view. Thank you.
Yeah, thank you. So clearly data privacy is particularly important, but I suppose from a healthcare point of view, it's quite relevant that we should have some mechanism or framework in place, and I think we do have in healthcare, of a trial or whatever system is actually deployed. So one thing is the research that happens in academia and in healthcare, decision making for healthcare, and another thing is actually the process of translating that research into true systems of product which are actually deployed. So I think it's, in my view, it's really quite important to have a framework in place where actually this translation is not rushed, right, but actually is controlled. And healthcare is really one of those domains where this is, I believe, done with a certain caution because of the negative consequences that this would have on patients, right, in general, and humans in general, right? So I'm not sure whether the same kind of cautiousness is reflected in a lot of other domains. So Stefanos was mentioning before, this kind of technology, forget about AGI, actually narrow AI, how you want to call it. So is already going to go wild in the social network with our children and youngsters talking with the computers, so they're talking to humans. So there is a lot of safeguard there that is not really present. So what do you think, what's at the hurdle in order to do that? How do you see, for instance, Charles, this kind of, if you like, a trade-off between commercializations and capitalizations of AI versus social, safety of humans in general, right, who actually use these systems?
So, I mean, there's always this fear of being left out, right? That because one company or maybe the technology company is actually doing X, then we have to actually be there as well, right? But a mark of, let's say, experience in your industry is actually gauging what the appetite of that industry is. For the financial industry, most of the people that have actually released AI models, they're saying, we are actually using AI models in the back end, not actually dealing with the let's say, the front end where we're actually making, let's say, decisions for the customer. But what was actually mentioned as well with neurosymbolic learning is the concept of formal model verification. So your test scripts, if you're actually doing like normal testing, if you actually follow up on the formal testing of software, you'll find that those test scripts will not cover the whole surface of risk. And if you take the fitness of your data or fitness of your model to the problem that you're trying to solve, then you need to actually look at it with a wider lens than what let's say just your normal testing would do. So if we understand the constraints that we are trying to actually, let's say, to work with, and also to understand that those constraints are not complete because our knowledge of the world is actually measured, let's say, at specific points. So what we get, is a low fidelity model of the world. If we understand that difference, that weakness, then we can start to actually, let's say, work towards it. Now, in terms of what is it that is stopping us, I can actually just point to generative AI, that if you're not OpenAI, right, you're not going to get the A200 the machines that OpenAI is actually getting from NVIDIA. You have to wait in line, right? So you have to come back with this, pardon the word, killer application, right, in order for you to actually get the technology to go to the next level, right? So if I'm actually looking at, let's say, neuromorphic computing, the reason why we are not talking about neuromorphic computing right now is because there isn't a killer application yet. And yet, deep learning is a tiny fraction of what we've been talking about in this room, and it's taking up a lot of silicon, right? So if you actually look at companies like TSMC, you got the likes of ASML, all of that you can actually map it to actual memories. You can map it to the GPUs. But if you look at reservoir computing, you look at things like neuromorphic computing, like I mentioned. You look at the rest of the AI domain, you find that the reason why we're not talking about it is because we cannot scale it in the industry. That scaling requires architects that understand AI. It requires architects that understand hardware, and it requires all of them working together. And very few companies will have all those skills in one place. So things like when I said we need to be in rooms like this, is because in this room I can find hardware architects. In this room I can find people that will actually work on a particular topic and then they move on to do other things, but they will have actually delivered something that is actually useful for me to actually build on. So at the end of the day, it's, I mean, I don't have to punish like someone for actually saying, oh, you know what, your problem is boring, right? I need to understand that that is the level of attention that they can, they can actually put to that particular problem, and I need to take that outcome and make it into something useful. And that will take different skills that a lot of companies cannot actually cannot get up front, because if you're solving a problem where everything is defined, it's not, even for me, it's not interesting, right? But we are solving problems right now that do not have clear boundaries, and because they don't have clear boundaries, it means that I have to actually have the capability to actually flex my knowledge base, right? I need to learn from the people that are actually researching these topics and giving them the opportunity to solve my problems in my context.
And I hope in this kind of a group of interdisciplinarity that are also represented, we expert about legal considerations, liability, and ethical and social considerations as well. Okay, so I think I would like to open for the last 5 minutes the floor to the audience here. If you have any specific questions that you would like to ask the panel, yes. Is there another microphone? You can have mine.
Thank you very much for the panel. So I have a question to you, Ed and Charles. So you touched on the neuromorphic and the hardware. You touched on the robotics aspects. And I think from my point of view is that the problem that why robotics are so stupid at the moment, I mean, I have few robots that can't even stand for more than half an hour. Like, for example, power management or power consumption is an issue. Software management is another thing. Neuromorphic and new architectures, we have very fancy hardware, but we don't have a software that can manage or deploy models on these types of architectures. So in some way, I blame academics at some point because we focus too much on the models, optimizing the models, because they are very fancy, right? They give us papers and so on. But if you work on the data collection, for example, there are ways where you could collect supervised data collection and the label data, even in the wild. But the problem, this is not fancy in the academic world. So we need more work on the other aspects of the system, not just the models. I don't know if you agree on that, like the whole life cycle of development, whether it's robotics or the other aspects of hardware for AI.
So yeah, that's a very good question.
Briefly, keep going. I'll give you the microphone to the other first.
Okay, all right. So yeah, that's a very good question, because let me give you a few examples from semiconductors, right? I was actually looking at new business development for ASML, looking at the neuromorphic computing. The problem is not that we haven't actually got, let's say, the use cases, but let's say we've got today a lot of use cases in neuromorphic computing. The problem that you have is scaling that, that hardware, right? We are still in the infant stage of creating that, that semiconductor. So you're looking at companies like maybe IMEC that actually, they are doing a lot of research on how to scale up neuromorphic chips, because to actually just create those memristors, there are different methods that have actually been published, but none of them can actually scale in the same way as the CMOS semiconductors that we are talking about. The other part is, in order to actually get the silicon chips that we have today, the let's say 13 nanometer, 5 nanometer, you're talking about machines that are 6 stories high and cannot actually move by a nanometer, right? So that means you're talking about the cutting edge or the bleeding edge of research. Those pieces of equipment are very, very expensive. To actually polish one mirror, for you to actually get to 13 nanometer, it takes about a year. So if you've got that, then you need to actually build kinematics models from the robotics side that actually constrain the movements within the system, and that hardware in the loop is actually very difficult to get to.
Okay, sorry to interrupt you, but we're just running out of time. So maybe
I'll just be very quick.
Very
quick, yeah. I think in robotics, I don't think hardware, that side of it, is a limitation at the moment, but I think it will become a limitation. So at the moment, the robots that we have, they're nowhere near AGI, but they are, they do have some capacities, and we're seeing some breakthroughs in narrow space using current hardware. But at some point, that hardware will become a limitation, and then we'll need sort of fleshy, tactile hands, for example, that will then enable the next level of AI in robotics.
Okay, great.
Right. One word answer to this question, please. What do you want from the doctors in healthcare and AI?
So your question is, what will be an intelligent doctor in health?
I think I'm a medic, so what do you want from us to push it further?
Can you actually pass the microphone back?
So one word answer. I would say personalization for me.
Okay. And the rest of the panel?
I think easy access. If we think about the NHS right now, getting a hold of a GP is not very easy, and at least having a pre-screening that is accessible to everybody, even for people that, for example, are very far away from a GP, elderly people that cannot get to the GP is very important. So I think AI can help in accessibility a lot.
So one word would be fidelity, but I would like to have high fidelity models of let's say, the problems that we are trying to solve. So building digital twins and working with them both in training of the GP, of the doctors, and also when we actually are doing the treatments.
And Diane?
Final?
Yes, thank you for the question. And I think that
One word. Okay, we lost? Okay. So the answer is to be just one word, please.
I think that I also agree with digital twin because we can allow the personalized doctor in the crowd. Thanks. Sorry, this is broken.
Okay.
Yeah.
I think we are running out of time, guys. This has been a very interesting discussion, so this is not going to stop here. So there's going to be other opportunity in the day to approach the panel and continue with the further discussions on this topic, right? Thank you very much. Thank you, all the panels here, for the wonderful answer that they gave us, and apologies for the sound problems. Okay.